Okay, hi everyone. Welcome to our event with Professor Dr. Fabian, Decentralized Finance on blockchain-based and smart contract-based financial markets. My name is Jessica, and I'm currently the core member of THUBA, THUBA, the Tsinghua University Student Blockchain Association. So let me start first by introducing our agenda for this event. First, Brian, the vice president of our association, will introduce our association. And then I will introduce the speaker for our event today, Professor Fabian, and then also pass the mic to him. At the end of the event, we will also have a Q&A section where people can ask questions in either Chinese or English. So if you have questions, please make sure to ask the question in the group chat or in the Zoom chat. And if you have questions in the middle of the event as well, then feel free to just chat in the our chat box. Yep. So as you can see, sorry.
大家好，我用中文也复述一遍吧，因为还是有很多人可能就是这个英文不是那么熟悉。那我简单说一下，就是非常欢迎大家来到我们这个 Professor Fabian 的活动。然后我们这个活动呢是讲这个去中心化金融的，对，然后主要是讲它基于这个区块链和智能合约的一个金融市场，它是怎么样子。然后刚刚给大家介绍的是 Jessica Helium， 对，然后她来自印度尼西亚，她目前是我们 THUBA， 也就是清华大学学生区块链协会的一个核心成员，对那我觉得我这边再继续介绍一下我们这一次活动的一个具体安排啊，就是首先等一下我这边会介绍一下我们协会是个什么协会。随后 Jessica 会介绍一下咱们 Professor， 然后之后 Professor 就会给大家是用英文给大家讲一下这个他在 DeFi 这边的一个见解，对，然后之后我们可以有一个非常热烈的一个 Q&A 环节，大家什么问题都可以问，用中文、英文都可以问，用中文问的话，我跟 Jessica 都会帮大家去翻译，所以这个不用担心。对，最后呢，我们这个活动结束之后，我们还会有个集体合照的一个环节，这个大家要是不太想公开这个照片自己的那个摄像头的话也没关系，反正就到时候就不要太早退了，我们大家一起合个照就行。对，那接下来的话 well, I guess now follow up, I'll introduce THUBA about our association. So THUBA is the Student Blockchain Association from Tsinghua University. And since the day it was founded in 2017, we have always believed that the classroom and the libraries are not the only places for learning. And our goal is to bridge the gap between students and the industry, between the Chinese community and the international communities, and to let everyone work together to realize the potential of blockchain. We're actually a very diverse student association, people from all over the world. We have people from Pakistan, we have people from Indonesia, me in person, I'm actually from South Korea. We have people from the United States, and also the majority parts of our association are from mainland China. And we mainly host events with companies and organizations like Flow, Polkadot, Findora, Web3, those are the big titles, and professors from our schools and others, where in this event we have Professor Fabian. And we also invite PhD masters from our computer science lab for everyone who is willing to learn, to help connect the advancements of both the industry and the research field to our talented students, which is you guys, the audiences. And so with our dedications, we now have almost 2,000 plus members and a wide influence with our own WeChat official accounts among our students and the industry. And in the near future, we'll host more and more events to not only just our students like me, but also to anyone in the world who's willing to learn about blockchain. So that's about it for the introduction of THUBA. Now I'll pass it over to Jessica.
Yes, thank you, Brian. So as everyone can see in my share screen, I was sharing the information of our speakers today, Professor Dr. Fabian Star. Did I pronounce it correctly? Yeah, okay. And we're really honored to have him today. As you can see, he's really high profile. He's not only the managing director of the Center for Innovative Finance at the University of Basel, Switzerland, but he's also the finance and the professor of BLT and also financial technology at the Faculty of the Business and Economics. He's also got a PhD in crypto assets and blockchain economics, and he has co-authored a book titled Bitcoin, Blockchain, and also Crypto Assets. He has organized several symposiums and other challenges related to blockchain. Also the member of the organizing committee of a conference with the Swiss National Bank. Also co-initiated a project to secure academic credentials on the blockchain. He's also the board member of the first FINMA-regulated crypto asset manager, manager of the CBR Research and Policy Network on FinTech and Digital Currencies, also advisor to the Multi-Chain Asset Managers Association and also Blockchain for Europe. He also used to be a consultant for several different companies. Yep, so you can see that he's really high profile. We're really honored to have him here. And without further ado, let's welcome our speakers today, Professor Fabian. Okay.
There we go. So thank you very much, Brian and Jessica, for the kind introduction and the invitation. I think it's great what you're doing with the association. I think it's really important when you have a interdisciplinary topic like blockchain and where you have to bring people from various backgrounds together, that something like this exists, and it's really important. Now, we briefly talked before we actually started the session today that I also think that this international exchange is really important, that we bring these people together, and to my understanding, that is exactly what you're doing, and I think that's great. So let me try to quickly share my slides, and then we dive right into the topic. Can you quickly confirm? Can you see it?
Yep.
Perfect. All right, so I'm going to talk about decentralized finance on blockchain and smart contract-based financial markets, and it's actually also the title of a recent paper I've published with the Journal of the American Central Bank, the Federal Reserve Bank of St. Louis, be more precise. And it's basically like an introduction to the topic. So it's not a very math-heavy lecture or a traditional research lecture. It's really just to give you an introduction to the topic, and then I will also show you some results from our recent research and give you some insights on what we are doing. And also, and I think that's really important when we talk about DeFi, there is currently a lot of regulatory pressure on decentralized finance. Some of it may be justified and reasonable. Some of it is probably a little bit over the top, but I can also give you, to some extent, some of the remarks and the insights from my talks with regulators around the world. There is already a question. Let me quickly check. Ah, yeah, perfect. All right, Jessica, Brian, I would be happy if you could manage the question. As I said, when there are any misunderstandings or any questions that need to be addressed during the talk, feel free to just jump in and ask the questions right away. Otherwise, in terms of the overview, I will start with a quick primer on blockchain, on smart contracts, just to set the stage, to make sure that we all have a common foundation. I understand there are some very technical people also in the audience. For them, this will be very basic, but I also, to my understanding, there are some people who don't have too much of a background in blockchain, and it's just to get everyone up to speed and then build on that. Then we will talk about DeFi. So what is DeFi? We'll talk about various definitions. Why should I care? Why is it important? What is actually different when you compare it to traditional legacy financial systems? I will show you, as I said, some research findings, and then we will talk about regulation and go and conclude with some key takeaways. So let's start with a quick primer. When we talk about blockchain, I think it's important to understand that at the end of the day, it's really this collection of various technologies that already existed before, with the goal to create essentially a data structure, a database that is managed by the community, managed by everyone, where just everyone has the opportunity to validate if all of the transactions are correct, mathematically validate, see if the current state of the database actually corresponds to the actual state. And what you need for that is essentially three things. And obviously I'm oversimplifying, because usually when I explain blockchain, I have like 25 hours with my students. Today I have slightly less, obviously. So we are oversimplifying. But the three main ingredients are, first of all, a peer-to-peer network. That is something you need. So basically this loose network, these standards where you can install your own client, connect to that network, and then basically just exchange information with anyone who's involved. And the great thing about that is it's really just a protocol. It's really just a standard. You may even, if you can do that, you may even create your own client. You might write your own software and connect to that network. And what is also important is that none of these nodes really are essential. So when some of these nodes go down, it doesn't really matter. There are alternative paths on which the information can be exchanged. When we talk about information exchange in the context of a blockchain network, it's usually two things. It's number one, it's transactions, which are just instructions either
Hey,
for payments.
Professor.
Yeah.
Sorry. Can you slow down a little? Some of participants, because their native language isn't English, so maybe it's a bit too
okay.
fast.
Yeah, make sure please to remind me again if I go too fast, because I'd say it's a really bad habit of mine. I'm sorry about that.
It's all right. It's all right. Thank you, Professor.
So just step in again if I'm falling back into old habits.
Yeah.
All right. So again, what you need is this peer-to-peer network where you basically exchange the information. So we are talking about transactions and blocks. And blocks is just a complicated name for collections of transactions. And that's number one. Number two, if you want to make, thank you. Number two, if you want to make sure that somebody is painting on my slides. Number two, if you want to make sure that these transactions actually originate from a specific person who has the permission for a specific balance, let's say, and if you want to make sure so that they are authentic and not being manipulated along the way, then you need some form of encryption. It's a special form of encryption. It's actually the other way around. You're usually doing, you also call it cryptographic signatures. And you do that with something that is referred to as public key cryptography. Now, if you're interested in how this actually works, also the math behind it, we have some open lectures online. So one of the blockchain lectures at the University of Basel is freely available for everyone to take on cryptolectures.io. And there we actually dive into the math. For today, you just have to believe me that it's actually working. And if you want to delve into it, if you want to look into the technology behind it, then I recommend this lecture. But the idea, again, is that you can verify that the transaction originates with a specific person and it hasn't been manipulated along the way. So when this transaction is just forwarded, that no one steps in and actually changes the content of the transaction. And then the last thing, we need a consensus protocol. That sounds really complicated, but at the end of the day, it's really easy. When you think of it, when you have a decentralized data structure where just every participant holds a copy of it, and you have no boss, you have no one who says that is the current state, so it's really decentralized, then you need some rule set, some form of being able to reach an agreement between these various participants. And that is usually referred to as a consensus protocol or a consensus mechanism. So the easiest consensus mechanism obviously would be if we just say, this person or this institution decides on the current state, and that is what you usually experience in traditional financial systems and legacy financial systems, or for example, when you're engaging with a commercial bank, they are holding these databases on your behalf. They are running these core banking systems, and they are essentially providing the consensus in the sense that they are saying that is the current state. With a blockchain, the idea is that everyone can contribute to that database, and everyone, more importantly, can verify that this is the true state. And with that, with this setting, with these ingredients, what you may end up, and this may is really important, is an open and immutable ledger. So really an open and immutable infrastructure where you can deploy various things on, so applications, protocols, can be used for various things. And that is what we usually refer to as a public blockchain. So there is one more thing, and unfortunately there are various misunderstandings when people talk about smart contracts. I mean, it's a term you can read pretty much everywhere. It's in the media, it's all over the place. People usually think that smart contracts either are legal contracts, which isn't entirely true. I mean, essentially, these are just computer program scripts. And they also think that smart contracts, the strength of smart contracts, the advantage of smart contracts is actually that they're great for process automation. But I can tell you right now, if you just want to automate a process, there are much better ways to do that, much more efficient ways to do that than with a smart contract. But really what really are the key characteristics of a smart contract is the security. So again, the verifiability that everyone who is participating in this network can verify the correct execution, can look into the code ex ante, so they know exactly what is on the smart contract. They know exactly what should happen when you're interacting with it, and they can verify that what should happen actually is what has happened, and verify the execution, so to say. And but it's also really important, especially when we talk about decentralized finance. And decentralized finance consists just of protocols that are made up of these smart contracts, is that these smart contracts can control assets. So they are essentially just addresses, just like an address when a user controls it, and they can take over control of some assets. So you can send tokens to them, they can be built as an escrow contract and so on. Some examples for things you can build with smart contracts, and we will also look into some of them, are decentralized exchanges, for example, where you build an entire decentralized token exchange just on various smart contracts. CFMM stands for Constant Function Market Makers. We will briefly look into an example of Uniswap. You can have collateralized loan systems, so basically emulate lending and borrowing markets on the basis of smart contracts. Or you could create something like synthetic assets, where you have price trackers, let's say, of stocks and bonds, or of literally any asset you can think of on the blockchain in the form of a token. So what is DeFi? The first thing you have to understand is that there is no clear definition. The answer you get when you're asking this question really depends on who you ask. My personal definition is DeFi employs public blockchain networks and smart contracts to build open, transparent, composable, and non-custodial financial protocols. And I think it's really important to look into each of these words one by one really quick. So open just means that by default, there are no access restrictions. It is deployed on a public blockchain network where anyone can interact with. And of course, since you have a so-called Turing complete instruction set, that means you can pretty much program whatever you want within these smart contracts. You could have some access restrictions, and for some of these protocols, there are actually access restrictions. But by default, when you're just creating a protocol, it is possible to create it in a way that it is just open to everyone and really acts as some sort of this neutral infrastructure on the public blockchain. Then the transparency characteristic, it is transparent in the way that everything that is done on this network, everything that is done on this blockchain is mathematically verifiable by anyone. So everyone has the opportunity to just download the entire blockchain, look at the database, at all of the transactions, look at the execution, and make sure that nobody else cheated. That's really this access. This has a lot of pros. It's a great property, but also in terms of anonymity and data protections and stuff like that, it's also it can be somewhat of a drawback. That there are solutions to it, but you must be careful and make sure you handle it. Composability, you can really think of that like Lego pieces. That's the usual analogy people give. When somebody creates a financial protocol, a DeFi protocol, deploys it on the blockchain and it's up and running, then somebody else can create an additional DeFi protocol, write his or her own smart contracts, and just use the other protocol that is already up and running on the blockchain, the existing one, the previously existing one, connected to it. So basically saying, okay, my new protocol is using some aspects of the old already existing protocol. For example, if you want to create a financial product or a financial protocol on the blockchain that requires access to a decentralized exchange when some of the functions in your protocol are called, you can easily just use one of the existing decentralized exchanges. If we want to create some product that allows the user to create leverage, you may access within your protocol an existing borrowing and lending market and write some code that uses that existing borrowing and lending market to assume that leverage. And in that way, we have seen an explosion of financial innovation. It's really impressive and highly fascinating what is currently going on in the DeFi space. And I honestly, even though I have quite some experience with traditional financial markets and I used to work on core banking systems within various banks, I can tell you I've never seen anything like that in terms of just the speed of the innovation. I think that's really beneficial, and it's a great phase of experimentation where we will see a lot of new protocols, some of them that may be here to stay. And then non-custodial, that's also a really important property of DeFi. And especially when you focus on the D in DeFi, the DE, the decentralized part, there is no trust requirement for many of these protocols. There are unfortunately exceptions that don't clearly disclose that. But the idea behind DeFi is that it is non-custodial. So that means that you're always in control of your own funds. And more importantly, that there is no one else who can just run with your money. When you think of traditional financial markets, then much is based on reputation and on the trust we are placing on the traditional financial industry and the actors therein. But potentially speaking, when you're giving money to some custodian and there wouldn't be any regulation in place in the traditional financial markets, they could just run with it. And that is the reason why we need that much of regulation and have to make sure that there are all these audits, have to make sure that there are these binding rules. But the great thing, at least potentially, about DeFi is that you can program that, you can code that in the smart contract, many of these things, and use the smart contracts and the code as a custodian. So you don't have to trust any human, you just essentially post your collateral with the smart contract, it is locked there, and it will only be released when certain conditions are met. And that is the idea behind this requirement here, the non-custodial part, that really a lot of these trust requirements disappear. I just realized, by the way, I will never make it in that speed through all of my slides, but that's fine. I'm just going to skip one part. I think it's much better if we actually can have a discussion afterwards and you understand what I'm saying then when I rush through it. So that's fine. But just to warn you. All right. So this is the DeFi stack I've proposed in the FED paper. It's essentially a framework that will give you an understanding of how you can think of DeFi and what elements are involved in there. So the first component you need, obviously, is the settlement layer. And it's really just a complicated phrase for essentially the blockchain where everything is settled on. So whenever there's a financial transaction, whenever anything needs to be settled, and you see that transaction on the blockchain, and as a matter of fact, any of the applications of the protocols that we will deploy later on are also deployed on this blockchain. The second layer is the asset layer. It's really the tokens that are generated, and token here you can think of it basically as an asset with a special representation on the blockchain in the Ethereum context, and that is where most of the action in terms of DeFi actually is. There are two and a half important token standards. Is the ERC20 token standard for fungible tokens. So when we talk about homogeneous things, that's fungibility, like stable coins, where it doesn't really matter which specific stable coin you're holding within one group. So when you have a specific, like a stablecoin like Tether, for example, then every Tether should be the same, and that is when you're using the ERC20 token standard. And this is really just a set of interfaces. I can think of it, so it's a set of functions and events that are specified to make sure that all of these tokens adhere to certain standards. And then we have the NFT standards, the non-fungible token standards. That's usually 721 or 1155. Again, these are just a set of specifications how you create your tokens. But this is for non-fungible tokens. So when it's really important which specific token you're currently holding. Okay. And this is the asset layer. This is where the tokens are created, the assets. And then on top of that, you have a protocol layer, and that is where actually action starts, where you see these various protocols, these financial applications. So things like decentralized exchanges, like lending markets, like derivative markets, like asset management, and so on. And on top of that, once again, we have the application and the aggregation layer. And the idea really is that up until here, we're talking about smart contracts. And of course, everyone can access these smart contracts when they're interacting with them directly. But we heard the term Web3 earlier from Brian. The idea here really is that you have some front end and some Web3 connections to these smart contracts, to the blockchain, where people can easily interact with these protocols in a much more user-friendly way. And you have that as applications, but also in an aggregated form when there are various applications combined, when you have a platform where people can easily access various of these applications. And then we're talking about the aggregation layer. And that is really the stack people have to understand. That's also really important that basically you assume the security properties of the layers below. So if your blockchain isn't secure, it doesn't really matter what you're doing on top of it. Nothing will be secure quite easily. If your assets are insecure, so if there are backdoors, if there are expropriation functions or blacklisting functions or any shenanigans, then it doesn't really matter what you're actually doing with these assets. It doesn't matter when you have a secure decentralized exchange. When your assets are insecure, then obviously it's not going to work, and so on. So you can really think of this also in terms of the security properties of DeFi. So why should I care? I mean, that's nice. We have some understanding of the stack of these various layers. We have some understanding of the blockchain, but what is actually different? Why should I care about DeFi? And instead of just giving you dozens of examples, I want to actually stick to 3 of them, which I think are super exciting. And number one is usually when you're doing something with your bank, when you're doing something in a heavily centralized context, then you have to trust this institution. And that doesn't necessarily have to be a bad thing. I mean, one thing is for sure, this is much more efficient when you actually can trust this entity, but there are things that can go wrong. First of all, I mean, with this trust, as I said, there are some regulations usually alongside. You need to conduct some audits. There's some risk that there is a rent-seeking behavior of that institution in terms of economics. That's really, it can be somewhat risky. And also, I mean, even if this institution doesn't do anything wrong whatsoever, it's somewhat of a risk when there is an attacker or when there's something goes wrong in terms of the infrastructure. Decentralized infrastructure is just much more robust because it doesn't depend on one centralized node, and I think that is a really important aspect. Moreover, when you think of it, you really have the deterministic execution right here. This means there isn't any arbitrary decision making involved. You just look at the smart contract. You see the code and you know exactly what is supposed to happen, and you can actually verify that later on. So when you're sending a token to the smart contract, and call a function, a method, and do something with it, then you know exactly what is supposed to happen. Here, it's a little more complicated. Then with clearing and settlement, I mean, it's a similar advantage. When you're, let's assume there are 2 people, so Alice and Bob right here. Alice currently owns a yellow token, Bob currently owns a green token, and what they want to do is exchange these tokens. In a traditional setup, what you have is you have clearing houses, you have escrow agents, you have a settlement system. So really convoluted and cumbersome systems that involve various steps and various intermediaries in many cases, and therefore are super expensive and in many cases also slow. And with this technology, with DeFi, what you can do is you can create something that is usually referred to as atomic transactions or atomic settlement. You can think of it that there are 2 ways actually. Number one is that you're embedding both of these sub-transactions. So green from Alice, or yellow from Alice to Bob, and green from Bob to Alice. Both of these sub-transactions, you can embed them in one transaction and make sure that it's inseparable, so that it can only be executed when both of these transactions are executed at the same time, but you cannot separate these transactions. Then essentially what you're doing is you're removing the counterparty risk from the transaction. In a smart contract setup, what you could also do is just creating an escrow smart contract. Both of these people are sending the collateral to the escrow smart contract, and then when these conditions are fulfilled, the smart contract actually forwards the transaction to both of these people, make sure that both of them get what they have been looking for at the same time. And then if we've already talked about that, I mean, with traditional financial services, usually have silo services. There isn't usually too much of an opportunity to access the data from other financial service providers, in many cases for good reasons, but there would also be a lot of advantages when this data could be shared to some extent. Also, the services themselves usually are in a silo and aren't really interoperable. And with DeFi, you really have this programmatic composability where any of these protocols, any of these applications can interact with other smart contract systems and other protocols. And I think that's really exciting. So I want to show you some examples, and I'm actually going to skip the detailed analysis of the examples. I'm just going to say what I wanted to say right here on this slide, because I'm really looking forward to the Q&A and to the discussion and the exchange with you later on, and I want to have enough time for that. There are usually, I talk about 4 categories. So I talk about exchanges, derivatives, and synthetic assets, about asset management, and about lending. And obviously there is much more in DeFi, but these are just some 4 very broad categories you can go with, and where there are some good examples. Now, one thing I want to say in advance, the examples I'm listing here, it's by no means an exhaustive list, and it also does not mean that I am embracing these protocols in any way. So you've seen that also on my first slide. In no means any of this should be seen as investment advice. I am not an investment advisor, and I'm not encouraging you to invest in DeFi or anything like that. All I want to do is show you some protocols, give you an understanding of what is going on. And this really should be seen, and that is what it is, as an educational session on these protocols. So when we talk about exchanges, everything actually, decentralized exchanges, everything actually started with so-called on-chain order book exchanges. And the idea really was to create an entire decentralized exchange on a smart contract. So where everything, even when somebody just sends an order transaction that hasn't yet been executed and just is in the order book, it was an on-chain transaction, okay? And when you think of that, when every time you want to make an offer, every time you want to propose something, you have to send a transaction to that smart contract, and you have to change basically your previous order. When you think of the situation of a maker, for example, this is extremely expensive. You always had to adjust it. You always had to pay the on-chain transaction fees. So it's probably not the best and most efficient way to set up a decentralized exchange with these on-chain order books. And that's when people quickly came to the realization that maybe some off-chain order books would be better suited, where whenever you have the intent to exchange something, you just send it to a relayer. It's there, and the only thing that is actually on the blockchain is the execution. So you can still make all of these nice guarantees. You can still say that you have this atomic matching, these atomic swaps, the atomic transactions, but the order book itself is not hosted on blockchain. There are some drawbacks in terms of censorship when you're following that approach, but it's certainly much more efficient and therefore less expensive. And one of the projects that goes in this direction was inspired by the on-chain order books, and then used an off-chain order book approach, is actually 0x right here. And then you have, for example, an OTC protocol, the AirSwap protocol, that really just gives you essentially like standards, how you can request information, how you can exchange these tokens in an OTC, in an over-the-counter matter. You have like Balancer, Curve, to some extent Bancor, Uniswap, SushiSwap, all of these Uniswap clones that have shown up later on, that really belong in the idea in the direction of constant function market makers. And I'm actually going to say something about that on the next slides. I'm still going to show that. And then you have like an aggregation system with Kyber, where you have a smart contract that aggregates liquidity from various sources and basically has it there for a taker that can request these codes. Then you have derivatives and synthetic assets. Let me check the time. Yeah, I'm briefly going to show one example with Augur. I think that's a great one. But the idea right here is that you can create pretty much any asset. This can be like in the case with Augur prediction markets, but it could also be replicating shares, where you're following prices with a price tracker of, let's say, some Tesla stock or just any company, and replicate it as a token on chain. And UMA is pretty much the same. DYDX also, as you will see, besides in this category of the derivatives, is also in the borrowing lending market. And then you have various asset management protocols. You have the SET protocol, mainly for passive management. The Melon, now Ensign protocol, that is mainly targeted at active asset management, where you can set the rules for the asset managers in the smart contract, and then this person has to adhere to these rules. And you have Yearn and B token, you have various of these protocols, but the idea is really that you're creating a set of tools that people can set up their own funds, their own investment funds in this DeFi context. In terms of lending and borrowing, there are the two really large ones in the market setup that are Compound and Aave. The idea is that you have this pool. Whenever you have tokens, you want to lend to someone else, you just lend it to the pool. It's this pooled liquidity, and then other people can actually borrow from the pool. You always need to be over collateralized because we're in this pseudonymous setup. So obviously it wouldn't work, with one exception that I will show you later on, if you don't post any collateral. And we have Maker. Maker essentially allows you to post some collateral in the smart contract and then create some new assets, your stable coins, by locking up your crypto assets in the smart contract as a collateral. Decentralized exchanges, this is an example of the on-chain order book exchange of the first one I've talked about. This is something that you can find in my paper. Again, I'm going to skip for time reasons these slides. These are various different protocols that have been set up for decentralized exchanges. And this is something I want to show you because here we're really talking about these constant function market makers. And I promise that's the only somewhat, well, it's not really math heavy, but the only slide where we have some math involved in this slide deck. It's really the idea of these constant function market makers and how they work. When you have a constant function market maker, the way you can think of it is basically you have the smart contract, and the smart contract controls two tokens, an X token and a Y token. And you can also see that here in the graph. So here on the x-axis, you have the amount of X token, on the y-axis, you have the amount of Y tokens that are currently controlled by the smart contract. And then you have a super simple formula that you have to make sure that the smart contract will always adhere to. That's XY equals K. So X times Y must equal K. This means no matter how you adjust your balances of X tokens or Y tokens in this smart contract, when you multiply them, it always has to result in K. What does it mean? When you think about it, this really generates an endogenous pricing mechanism in the smart contract. So for example, when the initial holdings of the smart contract have been this Y right here and this X right here, so we're really on this point on the curve, this convex curve, and then somebody pays a certain amount of X tokens to the smart contract right here, and you can basically look up on the curve where you are in terms of Y tokens, and this delta here, this delta Y we're paying out, that this is what the person who just sent some X tokens to the smart contract actually receives in exchange for these X tokens in terms of Y tokens, okay? So anyone can just send either one of these tokens to the smart contract and will immediately receive the other token, and then it acts as an exchange just for this token pair. Of course, you can put various of these smart contracts in a sequence. So when there is no direct pair, or when then there are other options with a deeper liquidity, let's say, then you can basically daisy chain them together automatically and pretty much create markets for any two tokens, even if there is no direct connection between the two. Okay, and the idea, and that is the fascinating part, is that anyone can provide liquidity to the smart contract. So when you have an initial X and Y holding right here, then let's say me personally, I could say, okay, I also hold X and Y tokens, and I want to pretty much act as a market maker in this space. So let me post some liquidity to the smart contract. I'm going to put that in there, and thereby increase the K, obviously. But what is important is I have to provide the same proportion, so I cannot just give some X tokens and some Y tokens. It needs to be in the same relation that we're basically staying on this line. And then we have in UK, I am proportional owner of this pool. I am proportionally participating when there are fees generated in the pool, and everyone else can trade against it. I can trade it against these tokens. Now, I'm not going to go into details here, but one thing you have to be aware that's really important is there are basically two effects in place for the liquidity providers. On the one hand, they are getting fees whenever somebody trades against this constant function market maker. Then this person pays a certain fee, and this fee, since everything that is part of the contract gets proportionally distributed to the owners of that contract, anyone who has provided liquidity will also participate in the fees. But then, of course, when there are some major price shifts, so when you're deviating from the original price ratio, and you can actually see it much better here with the log scale, then there is something called impermanent loss. So basically, when you're moving away from the original price ratio, you would have been better off if you just held on to the original holdings, to the original allocation of X and Y tokens, instead of putting them up in the smart contract for a trade where somebody else could make use of the arbitrage opportunity to move the prices. Okay. But that is something that is really exciting. There is a lot of research going on in this area, and it has grown incredibly fast, that to huge volumes. But it's also really impressive that on really busy days, when some of the centralized exchanges actually went down due to the large traffic and they couldn't handle it, these decentralized exchanges, they have been up and running. So I'm gonna just very briefly show you the principle right here of these synthetic assets, but not explain too much. It's something we can also look into the Q&A, but the idea of generating these synthetic assets essentially is that you're putting some crypto collateral in a smart contract, then you're getting a new token out of it. In many cases, this is a stable coin, but it can also be literally anything else. So you could also have a synthetic asset, as I said, that is a certain stock or a certain bond replicates the prices of that. And when you want to redeem it, you just return the token you have created and get your collateral, basically free your collateral in exchange. Now, the way this works, and I hope you appreciate these animations, because you better don't ask how long it took me to create them. PowerPoint isn't my best friend with these animations, to be honest. But when you think of it, you have basically your collateral, your crypto asset collateral right here. And then you have your debt, that's the tokens you have created. Let us assume we're talking about the stable coin, US dollar denominated. Then you need some minimum collateralization ratio. So your crypto assets you're locking up in the smart contract must be above this line right here. And obviously you will have some price movements right here. So the price of the crypto assets can go up, as you have seen right here, and it goes down a little bit, and it goes up again, stays more or less the same. And then there might be a situation where it just drops down immediately and goes below this minimum collateralization ratio. And at this point, your position would be at risk. At this point, your position can be liquidated by anyone else in the system. You can think of it basically as an auction, or to compare it to a margin call, but in contrast to a traditional margin call, you don't actually have the opportunity to do something about it in many cases. And what happens right then is that your debt position, but also your collateral will be deducted. So somebody else pays back a little bit of your debt, but also gets some of your collateral, and usually at a very good price, so that they have an incentive to actually do that. Okay, and these are really these crypto collateralized systems where you're trying to recreate something that isn't natively on the blockchain. So really a synthetic asset with some collateral in the form of crypto assets. Well, that's Augur, what I previously just teased quickly. It's a prediction market basically. Here you can see, for example, with the American election with Donald Trump, there has been a market created, yes, Trump or no Trump, where people could buy these tokens, could bet on it. And I'm showing you this example for one simple reason, to demonstrate the composability and why it is so exciting. So Augur itself isn't exactly liquid. Wasn't too much trading going on, but then somebody combined it with one of these constant function market makers with balancers and created something that's called catnip exchange. And on this exchange, they made sure that these tokens immediately after they have been created could have been traded against this constant function market maker. And this resulted in a new protocol, so in a combined protocol, so to say, that allowed for very liquid trading during that period. And it's just, I think that's really exciting about DeFi. Not these projects per se. I'm just talking about the composability and the idea that you can recreate something by combining various of these protocols. Lending markets, I'm actually going to just really briefly mention that again. You have this liquidity pool. Some people will lend liquidity to the pool. Some people will borrow liquidity to the pool. What you need to understand is that there are two different kinds of lending markets borrowing and lending in DeFi space. Number one is really the markets themselves. So like Compound and Aave, where, as I said, some people are contributing liquidity, other people are taking out liquidity. But then there's also the systems like DAI and Synthetics. So MakerDAO, the DAI stablecoin, Synthetics with the SUSD stablecoin, where essentially you don't have any counterpart, you're just locking up your own assets and then take out liquidity in the form of a newly created stablecoin that is secured by your crypto assets, as you have just seen in my graph. And the difference between these two systems, I mean, they serve a similar, they have a similar idea behind it. Basically, you just want to keep exposure to your crypto assets and take out some liquidity in many cases. But the difference is here you're really on a market, and here you're basically creating them yourself by locking them up in a smart contract of these respective systems. Now there is something that's actually much more exciting, because it's great and it's really important infrastructure. And I think these are cool protocols, but there is something that is completely new and couldn't be replicated in this form in the traditional system. And this is flash loans. Now, traditionally, when you're giving somebody else a loan, then you either need some collateral in the form of, let's say, real estate, in the form of assets of any kind, really, and or you need to know this person's identity to make sure that when something goes wrong, you actually can sue them. You actually have a chance to get your money back through the legal system. And the fascinating thing about flash loans is that they do not require any of these parts, yet you can be absolutely sure that you will get your money back. It is somewhat limited in terms of the application, as you will see, but it's still super fascinating. Now, to actually look what flash loans are, let me propose an alternative name, because I don't really like the term flash loans. I think if we would be talking about conditional sandwich loans, it would be much clearer what we're actually talking about. And conditional sandwich loans, because when you think of your transaction as the sandwich, then you have the two bread slices. And the first bread slice on the very top is you can get any available amount X from a liquidity pool. So you can just, if there are, let's say, 100 million available, you just can freely take out these 100 million for this transaction, as long as you also pay back this 100 million plus the interest and potential fees at the end of the transaction. Okay, so you really have this basically to set up this framework of the transaction, and these two parts, these two bread slices, they are inseparable, and they have to be both successfully executed in order for the transaction to actually count and lead to any state changes. If something goes wrong right here, if you're not paying back, then this entire transaction will fail. Why is this important? Because between these two bread slices, you can add arbitrary code. You can do whatever you want in the DeFi system. You cannot take the money out because this is really just one transaction. But within the DeFi system, you can execute any number of steps. For example, arbitrage between various decentralized exchanges, some collateral swaps, you name it. I mean, you can do really a lot, as long that you're paying it back. If this last step of the transaction fails, anything you're doing here will not have any effect. So you can think of it as like a time machine where everything gets rolled back, the entire sequence. You will still pay the transaction costs, but it will not lead to any state changes on the blockchain. Again, the two key principles: atomicity, so there is no partial execution. It will fail if this last step does not succeed. And number two is there are really two funding sources. Number one, it can be from pooled liquidity. So when you really have a liquidity pool, and number two is flash minting. So for certain tokens that allow for that, it would also be possible to say, okay, for this one transaction, you can actually create additional amounts of this token as long as you're paying it back plus some interest at the end of the transaction. When you think of it in terms of a payout diagram, so if this is your profit, then we have here the amount X that you're actually taking out, 1 plus rho. This would be the amount plus the interest you're paying. This epsilon would be the transaction fee, the network transaction fee for the Ethereum network. And var phi right here would be the flat fee you're paying to the contract to take out the flash loan. So when you think of it like that, then you would have this area right here, where it is not executed, but you're still paying the transaction fee. Then you have this area right here where it would be executed because you are able to pay back the minimum amount, but it still may result in a loss. Not as bad as if it is not executed, but still a loss. And then there's this huge area where you can come up with an execution with profit. Now, why does it matter? Why is it important again for arbitrage? And I think this is really important to understand. Usually, arbitrage is a game just for the big players. You need a lot of capital. You have a lot of requirements. Here, you don't need to bring any capital except for the transaction fees you're paying to the table. You can take out big time money, do something with it, and then pay back the amount plus interest, and any remainder, anything that's left over basically belongs to you. Then collateral swaps and deleveraging. I mean, many of these actions in the DeFi portfolio, they require lots of steps, especially when you're heavily leveraged. And this can be really expensive when you just have all of these steps. And in many cases, it can be much less expensive when you just take out the loan. And then you have much more flexibility in operating, shifting your portfolio when you have larger sums of money available. Then you usually can skip some of these steps. And also, of course, there are some flash loan attacks. And I dislike this term because it's not the flash loan's fault when something like this happens. What usually happens is that there are some poorly developed protocols with some poorly aligned incentives, and then somebody uses a flash loan to attack them because in many cases there are some capital constraints, some minimum capital requirements to conduct the attack. But what does it mean when you think about it? The attack would have been possible anyways. It would have been limited to people that have a lot of money. Only they could have executed it, but the protocol would have been vulnerable anyways. That is one of the statements I put up on Twitter, a governance security model that relies on capital limitations on the side of the attacker and allows this person to sell voting rights before the consequences of the vote are in effect is a bad idea. Flash loans do not cause these issues. They merely point out design flaws. And I think that is exactly what it is. A flash loan can show you when something is wrong because people have access to the money, have access to the resources, but it is not per se the issue when something goes wrong. I'm going to skip that. I'm also going to just give you the key takeaways of this right here. And I'm not going to actually use slides. I'm just going to talk really quick. One of the research projects we recently did was basically looking at DeFi, at the DeFi space and unwrapping all of these steps. So one potential issue in the DeFi space with the composability is that composability can also have some bad consequences when it is excessive. So when you have a token on top of a token, on top of a token, on top of a token, when you have various protocols that interact with each other that are, of course, in theory, highly transparent because you can always look at the blockchain and see exactly what they're doing. But in practice, it is so much work and really not that easy to find out what is actually going on, then you may run into some issues. And what we have done, it was just the first step in that direction, and also in a very limited context, is we've unwrapped these tokens to see to whom they actually belonged. Because when you're taking a naive approach on the blockchain and you're just looking at the current token holder structure, then you will see some top token holders that are in fact liquidity pools. And obviously liquidity pools the tokens that are on there on the smart contract, they belong to a lot of different people. And then when you're going one step down, you might see that there is yet another pool or yet another protocol that has contributed liquidity to this pool. And then you have to unwrap it again. And it may even be recursive to some extent. So it is somewhat complicated. So what we did, and this is joint work with a PhD student of mine, with Matthias Nadler, what we did is we've created an algorithm that allowed us to unwrap all of these steps, to undo all of these steps, and assign the tokens to the lowest owner. So these are usually an externally owned account, so a person, an account that is controlled by a private key, and look how concentrated these various tokens actually are. This is really important because for many of these protocols, we are really talking about governance tokens, where much of the governance decisions, so of the potential changes in these protocols, can be decided on by the current token holders. And if it turns out that many of these tokens are actually in the hands of just a few people, this may potentially be problematic. Now, I can show you really quick here just some of the top numbers. You can also just read that in the paper, but it turns out that it is quite different for various of these protocols. But in fact, when you just look at the top 50, that is the question, how many people are needed to control at least 50% of the tokens? There are some protocols where you're really in single digits. So this means that there are just a handful of people who are actually in control of over 50% of the tokens. And at that point, of course, it is questionable whether it is actually decentralized. Now, this may have changed a lot. This data is from November 2020. We are rerunning it. It's currently in peer review, this paper. But it gives you some insight that it's not that easy, and there might be maybe some governance issues with many of these protocols when you talk about voting rights, when 50% of the tokens are actually controlled just by a very limited amount of people. Now, that was our original goal of this research, to find out, to unwrap everything, but we actually came up with something much more interesting, and this is a term we've dubbed wrapping complexity. And it's really the idea that when you have this token on top of a token on top of a token, when you have one base token, how many times on average is it actually wrapped? And can we see that this complexity is actually increasing? That may be an indicator for systemic risk when you want to frame it negatively. It also could show that it's really interwoven and shows the innovative potential of these tokens, of these protocols. But it certainly shows you that there is a lot more action than there used to be. We split it in terms of internal staking, external staking, in terms of automated market maker liquidity, that is same as constant function market maker liquidity, lending, borrowing, and auto. And you can see that for many of these tokens, again, the full graphs are in the paper. For many of these tokens, you can see that there has been a huge increase towards the end of 2020 when the DeFi space exploded. What about regulation? I think that's really important. I have no legal background whatsoever. I'm an economist / a computer scientist, but most of the work I'm currently doing is talking to regulators. It's kind of funny. I came into this role because of that paper. I've been approached from various regulators around the world. And I mean, obviously many regulators, many policymakers are somewhat concerned when you suddenly have this system that may potentially be completely decentralized. Many of the traditional regulation doesn't work anymore, and you don't know exactly what's going on. So this is an active discussion around the world. There are many different proposals, and will be super interesting to see what will actually be happening in the next few years. Now, unfortunately, usually, I mean, there are exceptions, and there are obviously there are great policymakers in the space and regulators as well. But the two archetypes of regulators and policymakers I usually talk to are either the regulate them all type, so somebody is really concerned and just wants to regulate everything, and the don't touch any of them type. So really the two extremes. I think these two approaches are really both wrong, because the truth is much more nuanced and requires research. What you definitely should not do, and unfortunately in many cases that it looks at least that this will be done, is regulate something or not regulate something just because it is labeled as DeFi. The term DeFi itself, and I said that at the beginning of my talk, is somewhat ambiguous, and people tend to look at it from different angles, have different opinions what it is and what it should be, and therefore you have a huge heterogeneity in the space of what DeFi actually means, from extremely decentralized protocols that cannot really be regulated and where there might not be a good reason to regulate them in the first place, to extremely centralized protocols. Now, when there is true decentralization, then it can provide a mutually beneficial and provably fair infrastructure, and it may decrease the need for and the effectiveness of regulation. So again, when it is really decentralized, then it may first of all not be possible to regulate it. What you can do is regulating the on and off ramps, and that's a good idea, but you cannot regulate the protocol itself. And also, since you know exactly what the protocol is supposed to do, it's in the code, there might not be really a reason to do it in the first place. So it might be just much more efficient in that sense than the traditional financial system. So my proposal, once again, for this kind of DeFi is regulate the on and off ramps. One thing you certainly should not do, and unfortunately there are some regulators around the world who are thinking about that, is regulating the devs and the protocols themselves. What I'm afraid of when this happens, so when you're basically trying to punish somebody for creating code, even if this person hasn't deployed it him or herself, is that you will see a lot more of these anonymous deployments, and that's hardly beneficial for anyone. Basically pressuring these people into a somewhat dubious corner of our society. And I really hope this will not be done, especially when these developers don't have any special privileges in their protocols in the first place, and in many cases cannot even stop them once they have been deployed. But, and this is also really important, there is a lot of decentralization theater going on, as I said, and many protocols are more in this category where they're saying, trust us, we are so decentralized. But when you're looking closer, and you can again use this framework I've proposed, you will see that there are many centralized dependencies. So for example, the settlement layer itself, the blockchain, can be heavily centralized to an extent where it's closely resembling just a proprietary database, a centralized database. Then on the asset layer, you can have off-chain collateral. So where it's basically just a promise to deliver something. For example, when I create a token where I say, when you're giving me this token, you will get an ounce of gold, let's say. Then you have some issue or some counterparty risk that isn't really resolved by the blockchain. You still have to trust me. And at this point, it's obviously not decentralized. At this point, you just trust me as a person that I will actually honor my debt and pay you the gold when you give me the token. Also, you can have things like blacklisting, expropriation functions in the token smart contract, and that would also not be really decentralized in that case. On the protocol layer, there are things like admin keys. So keys that give you access to special privileges in the protocol that in some cases allow you to change the protocol, where you have basically just a proxy contract that points to the actual implementation, and then you can change that pointer by just exchanging the address. Oracles, these are just external data fees that in some cases are heavily centralized. And in really extreme cases, there are even centralized kill switches where just one developer or one person can shut down the entire protocol. And then, of course, on the application and aggregation layer, there may be some front-end specific risks, suitability questions, advertisement questions. And I guess where I'm going with this is you really have to look at the protocol. When it is completely decentralized, as I mentioned before, and none of these things apply, then of course, again, you cannot and you should not regulate. But in many cases, it will actually be the case that on one or various of these layers, you will find centralized dependencies. And then I think it is also important to understand that there is no good reason why traditional regulation should not also apply to these protocols, when in some cases it actually resembles these centralized traditional financial services quite close. So key takeaways. Number one, interpretation of the term DeFi differs significantly. Regulators must analyze these protocols in great detail before deciding to step in or stay away. I think this is also a call to action to policymakers and regulators around the world that I personally think it's really important that they start recruiting now to be in a position where they actually can evaluate these protocols, where they can actually look into it, where they actually are able to understand what is going on. And this is really important to do that now, and basically to create the infrastructure in-house they need to later be ready to assess these protocols. And number two, in any case, not regulating something or regulating something because of its name is a bad idea, as I said. So you really have to look into the details. This is the paper much of the talk was based on. As I said, you find it with the Federal Reserve Bank of St. Louis, has recently been published. And also, if you're interested in the topic, again, we have recently published the crypto lecture. So this is an entire undergrad or bachelor's course at the University of Basel, where we look into public blockchains. In this case, with the example of the Bitcoin blockchain, you get the cryptographic parts behind it, the computer science part behind it, the economics behind it. You really understand what is going on. And this is open source, open access, freely available to anyone. I'm really proud. We just launched it like 2 weeks ago. It is based on an old class we've graded back in 2017 and constantly updated ever since. But this open lecture, we just announced that like 2 weeks ago, and we already have almost 1,000 students from all around the world participating in this course. And I think that's fantastic. And then, of course, the book, the Bitcoin Blockchain and Crypto Assets book, published by MIT Press. I've written together with Alexander Berenson. And that's also a great opportunity if you want to look into this topic in greater detail. All right, so that's it. And now I'm looking forward to the discussion. Thank you very much.
Thank you so much, Professor, for the very insightful session. There are a lot of very interesting points made. And yeah, it's a bit of a shame because due to time limitations, we had to like skip some of the slides, but no worries. So we have several questions already. We've compiled several, and I'll just share the list of questions that our participants have submitted during your lecture. Okay, let's see. Can you see it? This is
yes.
Okay, yep. So we kind of ordered the questions we grouped them based on their ideas, their like concepts, but feel free to address them any way you like. Yeah.
Okay, I'm just going to go step by step. I think that's the easiest. What does a protocol define? Yeah, that's a really good question, actually, because there are so many different interpretations of that term. In the context of DeFi, when we talk about a protocol, then we usually talk about one or more smart contracts. Okay, so it can be, for example, when we talk about the decentralized exchange, this can be either built completely on just one smart contract, but in most cases, actually much more complicated than that. And then you have this system of various smart contracts that are interacting with each other. And this is really the idea of a protocol. In contrast to the application layer, we have also seen on top of that is that the protocol is really smart contracts that are deployed on chain, and with the application, we are usually just talking about the front end that is built on top of it and interacts with these protocols.
Okay,
cool.
So yeah, sorry, Brian.
I think I'll do the hosting, and then maybe you can organize the questions.
Okay.
Cool. Thank you. All right, I guess follow up, we can go with the second question. It's more of a general question for DeFi in general. Like, is DeFi for wealth management? Oh, this is very personal, I think.
I think it's much more flexible than that. I mean, wealth management, I assume it's probably like asset management, right? Where you can create your own portfolio with various tokens. That's where this question is going. There are some protocols that allow you to do that. But I mean, when you think of DeFi, it's really essentially a new technology, a new way of using these public blockchains to replicate pretty much any financial service you can think of. So asset management certainly is one aspect of that, and we have seen some examples in that direction. But I wouldn't limit it to that. It's really anything you can think of in terms of financial services. Now, I don't know if I did actually respond to what this person had in mind. Maybe you can, if I didn't answer your question, feel free to come with a follow-up question in the chat.
Cool. All right, we'll keep an eye on the chat, and we'll go on with the second question. I think this question actually come from Jessica. Do you want to just raise your question?
Oh yeah, the second question, I'm still a little bit confused regarding the correlation between DeFi and smart contracts, the usage within asset management, wealth management, and etc. And along with the relevancy of all this with cryptocurrency. There's actually a question from one of our participants.
Okay.
And our friend here, he works in the in consulting industry actually, but also has some background in business and curious about this about these concepts, DeFi in relation with asset management, because lately he's heard that a lot of his friends are investing in cryptocurrencies, and then some professionals are also talking about DeFi and asset management. So our friend is wondering how exactly all this ties up together. What's the real examples?
I mean, when you have a public blockchain like Ethereum, you need some form of incentivizing people to take part in the consensus process, right? Basically to maintaining the ledger, maintaining the database. And that is usually where these cryptocurrencies or crypto assets come in, these native protocol assets that allow you basically to reward people for their services. And this can be proof of work, proof of stake, literally any other consensus protocol. But that is the relation between the blockchain and the crypto asset, the native protocol asset. And DeFi is really just something that is built on top of that through smart contracts. So you, first of all, you need a blockchain that supports smart contracts. And the most popular one in that regard is Ethereum, which has by far the largest community, developer base. This may change. I mean, there are many great other projects upcoming, but as of right now, it is Ethereum. And really the relation between these DeFi protocols and smart contracts is that these DeFi protocols are in fact smart contracts. So everything you do on this blockchain, even if you're just creating a token, the token itself is actually a smart contract that keeps track of the token balances of all the people that have interacted with this token contract. Very simple terms, and please don't ever quote me on that. But just how to think on it is, think of you have a database basically, right? Okay, the blockchain itself, and then you're creating an Excel file on that database that is your token. And when people are interacting with the token, what they're doing is basically adjusting the balances in the Excel file. You can think of it a little bit like that. That is the ERC20 token standard I have briefly touched on, that defines some functions. So basically gives you instructions on how people can interact with the smart contract. Defines some events that basically, you can, in most cases, it's just really for front ends when they have to react to it or when you have to do some data analysis. But it's really important to have these standards in place, because when everyone would just create their own token with no standard whatsoever, these tokens could not be used in a DeFi ecosystem. You had to specifically code every single token in your protocol and make sure that this new token actually works with your protocol. Whereas when you have a standard like ERC20, where everyone has to adhere to, or not has to, but has a good self-interest to do so, then it's much easier to create protocols that can interact with many of these tokens. But again, I mean, DeFi is built on smart contracts. Smart contracts are deployed on the blockchain, and the crypto assets are really just a way to incentivize people to take part and contribute toward the consensus.
Cool. Maybe I can add just a little to that. If you want to, you can imagine, as a blockchain, let's imagine it as like iOS or Android that we use like in our mobile phones. And, the smart contracts will be the applications on those systems. Those are the little applications that we use. Inside that application, there are its special mechanism or rules that is defined. Those are the smart contracts-ish. So smart contracts are basically just built on top of public blockchains like Ethereum and stuff. He actually followed up with another question. He said, I was wondering if DeFi could keep the value of wealth itself, so it would not be decreased by inflation.
I think this is really nothing I can answer in general, right? This really depends on the specific protocol and the token. And I can give a general remark. I think, honestly, when you look at DeFi right now, it really is somewhat of a really dangerous territory. And you can think of it basically as the Wild West, really the frontier of financial innovation, where there is a lot of exciting stuff, but also an unbelievable amount of risk. So when you're engaging with these protocol, there can go so much wrong, especially when you're going to some of the more exotic protocols, and you have to be really, really careful. And the specific risks, I mean, there are some general risks, of course. Then you have the risk aggregation through composability. You have some ERC20 related risks that really are to some extent involved in many of these protocols, but then again, you have some protocol specific risks. And unfortunately, there are also a lot of people who are trying to scam you in this space whenever there's something new coming up. So it's not a question I can answer in general. Just one advice: be careful.
It's about investing. So you kind of have to just do your own research and make sure that you're betting on the right protocol.
Yeah, and one more thing, maybe, if I may add. I mean, the best investment you can make is just investing in your own education and actually studying these things and look at what is going on. And I think gambling on specific tokens and specific protocols usually is not a good idea.
Yeah. Know what you're investing, right? All right. I guess we can move on to other questions. So the other one will be, what do you think about the balance between public and privacy for smart contracts?
I'm not sure if I understand the question correctly. It could be either. It could be a question. It could be.
Can I just speak right now?
Yeah, sure. You can explain.
Yeah,
please.
I propose this question because just now we talked about that in DeFi, every code is represented on the blockchain, right? And it's public and everyone can say it. However, for some commercial privacy, for example, if I have a strategy for the investment and I want to keep it private, so what's the balance, or how do we solve this problem?
Oh yeah, I mean, you're completely right. And it's a pseudonymous system, so you're not writing your name on there, but you're right that once your pseudonym leaks, so when people know your address, for example, they can see exactly what you've done. They can basically track you. So it's not a very private system. The good thing about that is that it is transparent. So if you want to frame it positively, it has some nice aspects, some nice properties, but you're absolutely right. For some applications, this may not be well suited. Now, you can do some things about that, and when we don't have time to go into layer 2 solutions, for example. It's possible to do various things right there. Of course, you could also talk about side chains, more private side chains. Of course, you can talk about completely different settlement layers that potentially aren't prone to these issues. But as a general rule of thumb, when you have something that is completely decentralized and allows you for a certain set of flexibility, then it will also have a certain amount of transparency. And this may be good or not, but it is a fact.
Cool.
Okay,
cool.
Thanks.
Okay. I guess that was a good explanation regarding the current, traits of smart contract. You just have to give up something to gain something. Well, I guess the follow-up, we can ask the question of, earlier you asked about on-chain. Earlier you talked about on-chain and off-chain. Can you help elaborate more about these concepts?
Absolutely. I mean, it's really not that complicated. It's really when something is on-chain, then it is on the blockchain. And when something is off-chain information, then it is not on the blockchain. And I think I made that remark in the context of the order book. And when you have an on-chain order book, then every single order, no matter if it gets executed or not, is actually stored on the blockchain. And then whenever you want to change it, you have to send a new transaction to the blockchain and update that. Whereas when it is stored off-chain, then you usually have a relayer where you send the instructions to. You can just sign that, but the instruction itself is not a blockchain transaction. This is, of course, much more efficient, but also depending on how it is implemented, it creates some dependencies on that relayer and is prone to some censorship. So again, as always, you have some pros and some cons depending on what you want to achieve. One or the other may be a good solution. Now, if I can add one more thing, but when you hear on-chain and off-chain, it's usually also part of the scaling debate. It's not just used in the context I have used it today with the decentralized exchanges. So in many cases, when we're talking about blockchain scaling, so getting a higher number of transactions without losing the decentralization properties. And there are various ways in which you can create so-called off-chain transactions that aren't entirely reflected on-chain immediately. I just usually post some tiny amount of call data on the blockchain or some tiny fractions of the data, and the rest is handled off-chain. And the general idea behind that, so the intuition is that usually the blockchain doesn't have to handle everything, as long as all participants have the option, in case something goes wrong, to turn back to the blockchain and use it as a dispute resolution mechanism, basically as a court, and then present some proof and make sure that everything goes right.
Oh, okay. Thank you for the very in-depth explanation. It's a bit more technical, on the more technical side, yeah. But the concept is basically that you have these different sets, and they will determine the actual user experience of the blockchain. Okay.
Yeah.
Well, the follow-up question is actually my question. So it's like, what's the downside of, you know, for Uniswap, we're using K = YX, right?
Mm-hmm.
That's the equation. But we know that, you know, because of this equation is not that stable, it really affects from the token price, right? And there are quite a lot of hacks happen before. So, and can you give us some more of a comprehensive image of what are some of the possible risks of this equation and how we can improve this?
Yeah, absolutely. I think there are a lot of drawbacks. I wouldn't necessarily call hacks one of the drawbacks from the XYK model, because it's relatively simple and therefore, at least so far, it's been relatively secure, and it generally is regarded as relatively secure. But the big downside to a simple XYK model, as you state correctly, is that you're basically just reacting to the outside market, right? You're waiting for somebody else to come in and trade against your pool. So when you have, let's say we have a centralized exchange and you have some price fluctuations on there, some volatility, then basically you're waiting for arbitrageurs to correct the differences that are emerging between your so far static constant function market maker and the somewhat more dynamic centralized exchange. And when they come in and send some transaction against your CFMM, then they are adjusting prices. You're basically waiting for them. Now, the number one that may be problematic in that context, and I briefly mentioned that during my presentation, but it was really fast, is divergence or impermanent loss. So basically, when you have this movement just to one side, when one token of these two tokens constantly appreciates as a relative appreciation, then you would have been better off in just holding these two tokens. In most cases, obviously, it depends on the fees you're accumulating, but in most cases, it would have been better off. And the second one, and that is something that is actually true for most decentralized exchanges, is front running. Since you can observe the transactions when they are incoming before they are confirmed, right? They are in something called the mempool. So in this in-between state, everyone can see them because they are waiting to be confirmed, but they are not yet included in the blockchain. And then you have some, first of all, bots that are trying to front run and actually also back run, so sandwich these transactions. And also there's a concept, and that is one of the research frontiers currently, of miner extractable value, MEV, where depending on the miner and what software they are running, when they are optimizing, they can rearrange the order of the transactions and put some transactions of their own in there, and therefore make some profit just because somebody else is trading. There are some solutions to get around that also. I mean, you can define the slippage when you're trading against the constant function market maker, the maximum slippage. This also prevents some of these attacks, but these two certainly are some downsides to CFMS.
I see. So it's like, well, let's say about the miner changing the order of the transactions. So it's like, well, that can be solved in the smart contract level. It has to be solved in the public chain level, right?
Absolutely, and it's actually not a trivial question to solve.
Yeah, but it's just right now Ethereum is so already widely available, and it's very hard to upgrade its protocol, so that's why it's not solving, right? For now.
Yeah, and also, I mean, when you think about it, even if you have the opportunity to just change it in a completely decentralized context, and you really, when this decentralized property is of importance and you want to stay true to that, it's actually not that easy to come up with a good solution against minor extractable value.
I see. Cool. Thank you for the comprehensive answer. And below it, we have a question asking, which AMM do you think is the best, Uniswap or Dodo or other design?
I don't think there is a best one. Again, it always depends on what exactly you want to do. And some of them, they support more than 2 assets. Some of them are more targeted towards stable coins, for example, with pricing functions that are optimized for that. Some of them are, there's a new one upcoming and that is actually dealing with the issue of MEV. So I don't want and I cannot answer which one is the best one. I think it's just great to see this explosion of the innovation and see all of these experiments. And again, depending on the pair, depending on exactly what you want to do, you might go with one or the other.
Cool. Yeah, there are a lot of MM options out there, and yeah, it is definitely really hard to choose the best one. All right, cool. I guess we have 2 more questions. Well, this one is more general. I asked it as well. So what do you think is stopping CeFi to migrate to DeFi?
Yeah. I want to actually answer that in a somewhat more broader context, because what I'm currently seeing with my discussions with various banks around the world is that there is a huge interest in DeFi. And that actually took me somewhat by surprise. I wasn't expecting that, because with public blockchains in the early days, banks didn't seem to have that much of an interest. That completely changed with DeFi. They are all over it and they're completely interested and want to do something. And now what we're seeing from both sides, so from the banking side, they are approaching this sector. On the other hand, you have various players in the DeFi space that to some extent cuddle up with the financial intermediaries and also move a little more to the middle. So there definitely will be some joint projects, and there will be a lot of action in between. And that what will be the question in the next few years is, can the DE, so the D part in DeFi, remain when the institutional players come in? And I'm not absolutely convinced. I think what we will see, unfortunately, is that there will be some completely decentralized projects, but probably a minority, and they will not be touched. They cannot be touched by regulators. Obviously, financial intermediaries can also not engage with them because they are subject to regulation. And then there are some hurdles, challenges for them. But then I think that's really unfortunate. I think much of the DeFi space will actually just move to something I would call on-chain CeFi. So where it's completely centralized, but just conducted on-chain. Has some nice properties in terms of the transparency, because you can still look at what's actually happening. But obviously, much of the non-custodial features and trustlessness will likely disappear. And I hope I'm wrong, actually, but it doesn't look that way.
Do you consider those on-chain CeFi? Well, will those chain be like I guess permission blockchain instead of the public blockchain that we use nowadays?
I mean, there's certainly all some permission blockchains that also go in the direction of financial applications, right? I mean, we are already seeing that. But I wasn't talking about that. I mean, even on Ethereum, just because you have I mean, it's a precondition, but it's not sufficient to have a decentralized base layer. Even on a decentralized base layer and a decentralized settlement layer, I could still deploy something that is heavily centralized on the protocol layer.
Yes.
And that's what I'm assuming is going to happen.
Okay, cool. That really cleared my question. Okay, well, now we have final question. Well, I actually have a little bit more to add to that. So the question is, what do you think is the future of DeFi? And to be more specific, what's the latest trend of DeFi? And is there any new exciting ideas showing up in the field of DeFi that we should keep an eye on?
Yeah, I mean, the first part, again, I'm not sure if the decentralization part will play that much of an important role in the future, unfortunately. I think for certain protocols, absolutely. And the great thing is once you have deployed it, it will be running as this infrastructure, but I assume that much of these protocols go more in a centralized direction. In terms of latest trends, there is much research going on, as I said, in terms of the miner extractable value, in terms of optimizations with AMMs, much on the synthetic asset side. That is also something that is super exciting. With flash loans, flash minting. I mean, there are, honestly, it's so hard to keep track of all these things because at the end of the speed of innovation is amazing. It's great. And then also, that's probably the most exciting part is the interest of the financial institutions that are coming in and what this actually means for DeFi. I mean, that's something you probably all heard about with Aave Pro.
Yeah.
That the announcement that they want to actually create a separate market for whitelisted intermediaries, so mostly financial institutions, but in some cases also large players where they can basically use a copy of the Aave protocol, Aave Pro, as this market for borrowing and lending. And I expect to see much more of that. I mean, with Maker, we have seen also some steps towards real world assets with the real estate deal. They use it as a collateral. And I think that these boundaries, these borders between traditional financial markets and DeFi will slowly disappear. Again, this might also trigger some of the regulation. I mean, usually when you talk to regulators, they don't necessarily, well, obviously they do care, but they don't care that much when it's just in this little bubble of the crypto world. Not so little anymore, actually, but you know what I mean. But once you touch real world assets, I mean, it's an entirely different story. Once you create something that is interwoven with the traditional financial markets, then obviously, and I can understand that from their perception, there's much more at risk, and you have potential shock propagation. The traditional financial markets may have a greater impact. So I think besides the protocols where there's so much exciting stuff coming up every single day, the really interesting part will be regulation and how the traditional financial world will connect to DeFi. And that's something that I expect for the years to come.
Thank you. Yeah, that definitely solved my question about this. Yeah, we'll see if DeFi will become a thing in the future or CeFi will actually, take back the position. We'll see. Well, I guess at last, now at the final session of our event, we're gonna take a little group picture. So if you don't mind, turn on your camera, please do so, like right now. Yeah, we're gonna take a group picture and then we'll say bye. Usually people don't do it, but yay, there's one person doing it.
All right.
Yeah, just come greet our professor, right? He gave a really good lecture and I'm sure you learned a lot. Okay. I think this is great. I think this is great. But it's great to see Zio and Thomas. Yeah, thank you for showing up. And I'll take a screenshot soon. So say cheese. 1, 2, 3, cheese. Awesome. All right. I guess that's about it for our event. And thank you so much for all of you for attending our event. I'm sure it was, well, to me personally, at least, it was at least by far the best and probably the most comprehensive, most well-structured DeFi lecture I've ever heard. It was really, really good. And I'll share all the, the professor's lessons and his books in the WeChat group later. So feel free to check those out. And thank you all for attending the event. Thank you.
Thank you very much for having me.
Thank you, Professor. Thank you, Professor.
We hope to see you soon if you get the chance to visit China.
Sounds good.